Every single issue on this GitHub repository is a game of Doom. And no, seriously, open a new issue and congratulations, you just spawned your own Doom session. At this point, you're probably thinking, did this guy actually run Doom inside GitHub issues? Well, not exactly, but also kind of. Doom has become the engineering equivalent of can it run Doom? People have managed to run Doom on calculators, on pregnancy tests, on smartwatches, thermostats, inside QR codes, and to top it all, on bacteria. Basically, if it has electrons flowing through it, someone has probably tried to run Doom on it. So naturally, I wanted to run Doom on GitHub issues. Well, every issue on this GitHub repository is a completely independent game. Open another issue, that's another Doom world. Third issue, another game. Every issue has its own state, its own monsters, its own save, and its own history. Well, obviously GitHub isn't rendering 35 frames per second, and neither have I programmatically put thousands and thousands of if-else statements on every single frame as to what could be the next possible frame. So here's the trick. Everything starts with a GitHub issue. Opening an issue starts a new game and closing the issue simply ends the game. GitHub already emits webhooks whenever these events happen. So instead of polling GitHub every second, I'll just let GitHub notify my server instantly. Once the webhook is verified, it reaches my Express server. Now think of the Express server as the traffic controller. It does not run Doom itself. Its only job is to understand what happened, convert that into a game command, and hand it over to the game worker. The interesting part happens inside this worker. The actual Doom engine is written in C. It's incredibly fast, of course. It is an engineering marvel. But interacting with it directly from a web server isn't very convenient. So I use Python as an orchestration layer. Python starts the Doom runtime, sends keyboard inputs, captures rendered frames, and saves them as PNG images. Underneath, Doom generic exposes its frame buffer. Every time someone comments on the issue, I replay all the commands from the beginning. So instead of storing a constantly running game, the entire game state is reconstructed deterministically from the issue history. That means the server itself is mostly stateless. The GitHub issue becomes the source of truth. Open the issue, replay every command under the last frame, and you always end up in the exact same state. Finally, the rendered PNG is uploaded back to the GitHub. Well, you might think this is cool, but hey, this isn't good enough. Why? You are just replaying the game every single time. And that's leading to a time complexity of ON. Well, that shouldn't be happening. You know what? Let's just save the state and not replay the game every single time. The left side remains almost identical. GitHub issues still act as the controller. But after the webhook reaches my Express server, everything changes. Instead of immediately talking to Doom, every input first goes into a custom job queue. This guarantees that commands are processed one at a time, in exactly the order they were received. Behind the queue, now I have a persistent Python worker. Instead of launching Doom for every comment, each worker keeps the game alive in memory. Instead of starting the game again and again on every GitHub command, it's just press one more key.
So that changes the time complexity entirely to big O of 1.
And giving me a simple time of 2 seconds. Instead of replaying hundreds of previous commands, I apply only the latest command. Now, since multiple people can create issues simultaneously, every issue gets its own isolated game session. Those sessions are persisted in Postgres, along with the command history, metadata, logs, and the frame information. That persistence gives me another advantage. If the work crashes or the server restarts, another worker can simply resume the game from the stored session, so that players don't lose their progress. Well, to now make this experience feel more faster, let's just cache the first few frames. So the game appears to start almost instantly, while the actual Doom engine is still booting in the background. Finally, every rendered frame is uploaded to S3 and the GitHub issue is edited with the latest screenshot. And if nobody interacts with the game for the 5 minutes, the worker shuts down automatically to free server resources. The result is a system that is scalable, fault tolerant, and constant per time input. Instead of treating GitHub as a replay log, version 2 treats GitHub as a live Doom session. So that's how it turned one of the world's most popular developer platforms into something it was never meant to be. That is a gaming console. If you've got a crazy idea of your own, just build it. Because sometimes the best engineering projects start with a single question. What if?